Kia ora, and welcome to this topic, catalytic converters that you can choose for the 91163 standard. Notice there are the two parts to the standard, the development, and so for this topic, you would talk about having no catalytic converter and the problems that were associated with that, why it came in, the beginnings of the two-way catalytic converter and what influenced it in terms you think of leaded petrol, all those ideas come in, and then it goes to the three-way catalytic converter and why they added this extra chamber. You'll notice there are two chambers to three. Then you have to demonstrate the chemistry of the catalytic converter. So the level 2 chemistry you need to know is the 2071 redox chemistry. The rates on reactions, either 2061 or you can get away with what you've learned at level 1 if you did the 90944 standard, and complete and incomplete combustions that are done in fuels at level 1 or the carbon exam is also helpful. So redox chemistry, you have to know about oxidants, reductants, how to work out oxidation numbers, what they mean, how you work out electrons lost or gained in equations. Then rates of reactions, you'd need to think of the surface area, the temperature, the catalysts, and then fuels, as I said, complete and incomplete combustion is worthwhile knowing about and being able to talk about it. So the three cornerstones, as we mentioned, so the macroscopic, catalytic converter is a thing we use in a car and it's stuck right behind the engine. So think of why is it right behind the engine? Why isn't it further down? Why do we have these oxygen sensors both in front and behind? So you think of complete and incomplete combustion, the amount of oxygen. So again, it brings in your stoichiometry of your 91161 standard as well. So your ratio of oxygen to fuel is important. Then also think of the shape. Why is it long and thin? If we look at it, we'll see there's a big surface area, because notice it's broken up into lots of little parts with this honeycomb structure. Here's a close-up. Notice how rough it is. Why do we want such a big surface area? Those are the questions you need to answer. And here's another example, a picture shown. The microscopic, so here's just to show what's happening on the particle level, but here what you'd be explaining is you'd be explaining collision theory, and so the factors affecting the rates of reactions. You'll be explaining exactly what is losing electrons, what is gaining electrons, and why, using oxidation numbers to confirm. You can talk about the incomplete and complete combustion, and therefore the need for these oxygen sensors. So that's all your theory that you would bring in here. And here's an example where the catalysts are rhodium and platinum. So that's in the first chamber, and then the second chamber where you get oxidation, you have palladium and platinum. So those are your noble gases, and here's an example of sort of what happens if you've got your platinum surface area, the way it first binds onto the catalyst. It lowers the activation energy, allowing it very quickly to be able to form the carbon dioxide because not very much energy is involved. So that theory is what you need to bring out. And here's another example, but this is bringing now more the model. So we're looking at equations. Notice that it's an arrow, balanced, fully balanced, using subscripts and so on. So that's your model, the way you represent, and here's another way we can show it. But have these equations, you need a minimum of at least 3 to 5 equations in your report. So as a final note, make sure that it is all your own work. I strongly recommend that you watch the videos, read through the work, and make notes as you go, and then ask yourself questions and try and answer it in your own words, and use that material to then write your report. Type your report so you can modify it and modify and modify it. Please note that any diagrams that are just copied from the internet, it doesn't matter if they're quoted and cited and so on, we just draw a line through it because it is not your own work. All the best. Goodbye.